I'm going to assemble a new desktop PC. This is Intel Core 12th generation i5 12400. This is Intel Arc A770, the graphic device. This is the motherboard from Gigabyte Z690. To fully support Intel Arc A770, the CPU device must support resizable bar. Also, the motherboard should support resizable bar. I have to upgrade the ROM BIOS of this motherboard. The primary reason I assembled a new desktop PC is to use SQL programming over this new Intel graphic device.
Today is January 21st, 2023. This is my 200th episode for C++ 17 2023 CUDA SQL OpenGL OpenCL TBB Vulkan. This is 10th episode about vector calculus. In this episode, we will learn derivatives and gradient vectors. Example, we will solve example 6 from Thomas's Calculus 13th edition. To follow my current session, you need updated C++ library extensions. I updated this library today. I assume you have watched my previous videos listed here. From my previous episode 199, Vector Calculus 29. Please double-click this link. I assume you have watched my previous videos in this playlist. In my previous episode, Mr. DW, awesome contents, thank you. Are we expecting C++ implementation for this? Yes, I've already implemented. Horrible program. I can't find a lot of your videos. Sadly, is there a way to subscribe? Well, you can subscribe, but I don't provide membership service any longer. If you want to find my videos, for example, tuple, then use siliconians like this. Hit enter. Then you can find all videos about tuple. All videos I filmed about tuple like this. Now I will go back. Horrible program. You can search my videos with the following method. Keyword siliconians, where keyword is the text that you want to search for from my channel. For example, if you want to list all videos whose title include tuple, the keyword tuple, then you can type in tuple siliconians in the YouTube search box. Horrible program. Actually, there is no such thing as horrible program. There is no bad program. All programs are good. There can be less efficient program, less efficient algorithm, more efficient algorithm, more efficient program. But there is no horrible program. All programs are good. Open up Visual Studio Code. CPP 17 2023 parallel. Select empty space. Click this button. 200 gradients. Click this button. grad.cpp. Hit enter. Ctrl V. I will close this empty file. I will copy and paste this script. If you haven't watched my previous videos, you may have to watch them. Otherwise, you may not understand my current and future sessions. Also, you need to download C++ library extensions by control-click this link. Now, include CPG, SED extensions. Include CPG, calculus, namespace, CNA, CPG, numerical analysis, namespace, CPT, types. If you have such squiggle, okay, it should be resolved properly. Also, it is CPG. I would copy and paste these things into main, copy this function name, paste it in function main. Thomas's Calculus, 13th edition. Thomas's Calculus, 13th edition. From this book, chapter 14.5. Directional derivatives and gradient vectors. Scroll down. I assume you have read the theory in this chapter. If you scroll down, you can find example 6 in page 837. I will arrange side by side like this. Find the derivative of f of xyz x cubed minus xy square minus z at point P0110. We want to find derivative at this point. I would copy and paste it here. We have vector v. This is x cubed xy square at point P0. We need using namespace CPG, operators and constants, or f. We define this function here. I will scroll up. Oro x, oro y, oro z, don't miss semicolon. We return this expression, semicolon. We need parentheses here, underscore 3, parentheses, underscore here, or grade f, CNA, gradient vector. We pass this function here. Also, this point, like this, semicolon. Please understand, we have to provide floating point values, so it should be fixed. Our code like this. SED, Cout, grade f equals grade f CPG and there. So we expect this vector gradient f at this point. With this, open up your command prompt. dir cd 200 gradients clang ++ sed c++20 grade.cpp ltbb12 oc.exe, hit enter. cls c. So our gradient vector is 2, -2, -1, 2, -2, -1. Now u is unit vector defined like this. So we can say oro u. This is unit vector. CNA create BCTR 3D. We can create vector B. This is vector B, so we can say 2.0, 3.0, 6.0. I would set B. Please note that I used create vector 3D by passing 2, -3, 6. 2, it should be -3, 6. We can display, copy, paste. B, this is vector B. Now, ORO, U, this is unit vector OB, unit. We can retrieve like this, copy, paste. This is U, this is U. I will use Microsoft compiler. CLEHSC SED C++20 grad.cpp fe m.exe, hit enter. CLSM. So V is vector, this vector is unit vector, is this vector. This is unit vector of V. How can we make sure? How can we know if U is unit vector? That's easy. ORO MAG U. U magnitude. Copy, paste. Magnitude of U, we can say mag U. Now, here, the derivative of f at point P in the direction U is therefore dot product. So, ORO derivative f equals grad f. This is dot product with U. We are solving this part. SED, C out, we say grad f dot U derivative f. We expect this value. So 4.0 over 7.0 CPG, and then I will give a line break here. Now we want to display magnitude of gradient f like this. STD, C out, magnitude grad f. Of course, we can do grad f magnitude. We can do this. CPG, and in this case, we used member function magnitude. So this is magnitude of gradient f. But we can also do this. I defined typecast, for example, double. Then it gives magnitude. With this, we build again. We are using Clang compiler. CLSC. We can see magnitude of U is 1. So this is unit vector. Gradient f dot U is this value. We expect this value. Our gradient dot U, this value is this value. So our numerical computation here matches with the answer in this book. Also, magnitude of gradient, grad f is this value, as in this result, 3. Magnitude of gradient f is 3. So the value is 3. I would highly recommend you to read the theory about gradient. All these things. I cannot explain all the mathematical details. I assume or expect you read this book.